So in the last class, like the first demo class, we have an intro and have a high level picture of what is DevOps, how DevOps works, the CI/CD pipelines. We have got an understanding and brief overview on these topics yesterday, right? Today, let us start with the Git version control systems, and let's proceed deep dive into the concepts. Right. So we'll begin with understanding what is a version control system, who uses it, and why do you need to learn as a DevOps person. So let's begin. I believe you all can hear me and see the screen. Okay. Anything you have, you can let me know. You can unmute and speak out. So now let's proceed with understanding what is a version control system. Anyone using the version control systems or any idea, you can share your inputs before I proceed. Any input, what is a version control system?
Tool used to store different kinds of versions.
Okay.
Yeah.
Any more answers? Okay.
Tracking changes.
Yeah. Yes, please.
Yeah, tracking on the code change.
Change the source code, madam.
Okay. So let me give a simple example. Let's suppose you're working for a project. Okay, this is a project, and this project may have so many files, right? So much of documentation files, whatever it is, or code, whatever. So all of them will be managed in a particular shared folder, which could be shared across all the team members, right? I'm taking up a simple scenario. So this is the case. There were so many files kept on this shared folder or shared drive, and all the team members are accessing it. Let's suppose person A has to modify some file called file1, and he got this file downloaded. Okay, he got this file downloaded from his system, and he was making changes to this file1. Then person B also got the same file1, right? So from this repository, like from here, and he was also making changes. They both got this file1 at the same time. After 2 days, file1 was kept back by person A. Let's suppose after 2 days, or else let's say on Monday, he kept this file back after modifying his changes. And let's say this person B also modified this file and he kept his changes back on Tuesday. Here I'm talking about a simple scenario without using version control system. If this is the case, this file1 on this remote location will have which person changes after 2 days, or after, like, let's say you see on Wednesday, this file will have which person changes? Will it have both the person changes? Which person changes will be there on Wednesday? If you see the file, whose changes will be there?
Both of them.
Only person B changes will be there here on this file after a Tuesday, after both of them keeping them. Because what is happening here? Person B changes are overwriting person A changes, correct? Yes, it's been overwritten. Whatever changes person A has kept on Monday was overwritten by person B changes, because they both got the file at the same time from the remote location. So B doesn't have the changes of person A. Obviously, when he put back, these changes will be overwriting it, right? So if this happens with two members, imagine a team of 5 people. If they are not using any version control system, and if this is how they work with the files, obviously one person changes will be overwriting the other person changes. Am I correct?
Yes.
So meaning we need a system which can take care of this, which can allow multiple people working on the same file simultaneously. Correct? Right? It should allow people working on the same file at the same time. Like people can work on the same file simultaneously without overwriting. How is that possible? Yes, that's where we need a version control system. Is that the only scenario? What else you have? Let's suppose the other scenario could be application is working fine till 7:15 a.m. Something went wrong and application crashed. You can't access this application. You want to immediately revert or recover the previous state, right? So that the business doesn't go down. So how to achieve this? Yeah. So in this case, if you have a detailed logging, like if you have a system which can provide detailed logging, like file 1 was modified by person B at 7 o'clock or at 7:5 on line number 9. If you have this kind of detailed logging, which person made changes to what files, it could be very much helpful, right? Am I correct? Right?
Yes.
So we need a system which can provide this kind of detailed logging, right? That is another use case where version control system comes in, right? And another use case is, let's suppose, okay, you are working on file 1, version 1 is there. Client want to make some modifications and make version 2. Don't override this version and make version 2. Rather, maintain the versions. Because if you override this and made version 2, let's suppose you have overwritten the same file, made version 2. Let's say client doesn't like these changes and they want to revert back in few days. Is that possible? Right, because it's a rework, right? You have to do a rework. Again, you have to bring those previous changes. Rather, maintain the versions, maintain the backups. Don't delete the version or edit the version. Rather, you create a new version. So maintain the versions, maintain the backups. All of these are possible with a version control system. So version control system is basically which will allow people work on the same files at the same time. It will help in detailed logging. It will help in backing up, maintaining the versions, because as a person, you'll be working on the files, you'll be working on the client requirements. You cannot just work on these things, right? So that's where version control system comes in, which can take care of all these things while you work on client requirements. Am I clear with what a version control system is?
Yes.
Yes.
Right. So this is how it works. Now, if you look into, like, if you see like what are the who uses it, definitely it's used by developers. It's mandatorily used by them because they have so many program files and all. But even testers use this because they too have automation test cases, test scripts. Even DevOps teams, ops teams uses it because they do have their configuration files, right? They do have their Kubernetes config file, Terraform config file, Ansible playbooks. Even those should be version controlled. Means not only developers, okay, anyone and everyone in IT would need this. I would say everyone should learn it because you have to manage the files, right? In a professional way. Managing the file means maintain the backups, versions, provide their logging, detailed history of what changes went. So obviously, definitely everyone should learn this from the perspective of managing your code base, managing your files. This is one aspect of learning version control system. Another aspect is integrate into the pipeline. Whenever developer make a change, you should trigger the pipeline. So how is that integrated? Correct? So we will learn that also. So first we will learn here from the perspective of managing the files. Then we'll learn from the perspective of integrating it in the pipeline. Am I making sense? Got an idea who uses it? And also any static files can be version controlled. They could be Java files, C#, Perl, Python, whatever it is, irrespective of the language. Even text files can be version controlled. Any static file can be version controlled.
Okay.
Right? So now that we understood what a version control system is and why you should learn, it need not be developers. Anyone who have some files to manage can use this. So everyone in IT should learn this version control system. And now that we understood what a version control system is, let us see their classification. Based on their architecture, they were categorized as centralized version control system and distributed version control system. And how is the architecture of centralized version control system? If you see here, there'll be a central server or remote server, whatever you call it. Here, all the project work, all the code base would be kept, and every user, they might be a developers or DevOps person, whatever it is, every team uses it. So they will have a working copy. Means this is, let's say, imagine this is the workstation of each individual collaborator. So they'll get the changes to this working copy, make changes and put this back. Simple. But it has got challenges like to work with this, you need to have the network connectivity always, right? Network should be connected. So you need to connect to the remote server, get the changes and so on. So network should be connected. Network connectivity should be there, right? So what if network connectivity is not there, let's say network disconnected, entire work would be halted, which is a great challenge. Second thing is chances of recovery are less. Let's suppose for some reasons, this central server is crashed or lost, right? Chances of recovery are less because it works like a single source of truth. So recovery is again another challenge. These are some of the challenges of version control systems which follow centralized architecture. Examples of the tools which follows the centralized architecture is SVN, TFS, Perforce, and so on. All these follow centralized version control system architecture, but it has got these challenges. To overcome these challenges, we have something called distributed architecture, distributed version control systems, which is GIT. GIT follows distributed architecture. Can we proceed with the next type of architecture? Good to go. Any questions? Are you all with me following?
Yes.
Yes, ma'am. Yes.
How about this Bitbucket
Madam,
is also
centralized version control system is a local system or like a
No.
like a
Another type of version control system. It's not local, it's a centralized version control system. Another version control system with the architecture as centralized, suppose.
what is the full form of SV and TFS, madam?
I'm not sure. I think subversion or something. I'm not sure about the full forms. Those are the names of the version control systems.
SVN is a subversion. But how about Bitbucket? Bitbucket is also a simple
See,
one.
Bitbucket is different, GitHub is different. Those are not version control systems. Those are online management system to host your version control systems. I'll come to that part.
Okay.
We don't use these much. So full forms, we don't remember. SVN is something like subversion or something, TFS and so on. So there comes another version control system which follows distributed architecture. Okay, so if you look into this architecture, this is a central server or remote repository, and this is the workstation of each individual collaborator or developer or DevOps person, whoever it is. So
Are you sharing something?
are you all
Are you
seeing?
sharing your screen?
Are you all seeing the screen?
Yes.
Yes, I'm sharing, Sudarshan. Check.
Okay. All right. Yeah.
So this is
Thanks.
the workstation of each individual collaborator. Okay, they will connect to the remote repo. Okay, and get a copy of it. This is here you will see two repos. This is the central server or remote server. And this is the local repository, local repo. Okay, so they will connect to this local repo, get the copy from remote repo, make the changes and put them back. That's how they work. Again, they don't work on this local repository directly. Rather, they will work on some other directory called working copy. Right? This is how they work. Are you seeing it?
Yes.
So here what happens, everyone is having a local copy and they work on some other directory, move their changes to local copy. From local, they move their changes to remote. So unless they move their changes to remote, they are confined only for themselves, right? Also, even though network connectivity is disconnected, let's talk about network connectivity. Even though network is not there, it's disconnected. Still, entire work is not halted. They can work on their local repo, right? Means they can continue the work. Only to push their changes to central server, they need this network connectivity. To push or pull means to get a copy or to move their changes to remote, they need network connectivity. Until then, they can work on their local repository, which is quite faster because they have to just access their hard disk to work with this. Right? So even though network connection is not there, they can continue the work. Network connectivity is required to push the changes to remote. Only once they push the changes to remote, others, collaborators, other users can see their changes. Got it? Network is required only to push and pull, which are less frequent. These commands are less frequent because once complete work is done, you push to remote, isn't it? You don't need to push every now and then. Similarly, you get a copy once all the updates were pushed by others also. So those are less frequent. Majority of the work happens here. Because majority of the work happens here, it's quite faster as well. And then coming to the point of recovery, chances of recovery are also more. Because chance of recovery are more because even though the central server is lost or crashed, still they can get a copy because everyone is having a copy of remote, which is a local repository, right? Chances of recovery are also more, and Git falls under this category. Git is a distributed version control system. All the modern DevOps projects majorly uses Git. If you master Git, you can work in any project, like majority of the projects. Suppose some project is using any other tools like SV and TFS. Again, they would have similar logic. Conceptually, it would be almost similar. So switching also is easy. So always try to master one tool under each category. Here we are mastering it, which is very widely used in the market.
Git.
Is this clear? There is no full form for Git, okay? It's a Git. And yeah, this follows distributed version control system. What are other tools which follow distributed architecture? Mercurial, Fossils, all these uses distributed version control. But like I told you, right, Git is very widely used. It's a market leader. All the modern DevOps projects prefers using Git because of its robust branching feature and all, which we are going to learn as we progress. But is this much clear? Is the architecture of distributed version control systems clear for everyone?
Yes, Preethi.
Yes.
Is this local repositories for different teams like developer and testing and all that, or
Local repository is actually confined for yourself, right? It is on your workstation in your local computer.
no? You it's on the picture. It's showing like three different local repositories, like
That's
three. Mhm.
every user, everyone will have their own local repository in your computer. And also like here I mentioned D1, developer or DevOps person, everyone will have their own local repository in their local computer.
Okay, okay, thank you.
Like it could be, if it is development team, yes, every developer will have their own local repo. If it's a DevOps team, yes, every DevOps person will have their own local repo. That's why changes present in your local are only confined to yourself, unless you push to remote. Remote
Local
is,
is like our local computer, not like local server or local company team
yeah,
or something.
yes.
Okay.
See, here I'm giving you theoretical picture. We are going
Mhm.
to proceed and see all of this practically. So don't worry, you will see your
Okay.
local repository in few minutes.
Okay, thank you.
So this is the architecture of distributed version control systems. And yeah, this is a graph from Google Trends. This is a graph from 2020. You can also get the latest graph from 2024. You can see Git is clearly the winner in the category. Do you see the blue graph? No comparison with other tools. Do you see that? SVN,
Yes.
TFS, like the graph, you can see how much like widely Git is used when compared with other tools. You may also pick up the latest graph and see this. Right? So learning Git would be always advantageous and helpful. Master Git, that's enough. You can work on any version control system. That's for sure. Okay, now we understood the architecture of centralized version control systems. We understood the architecture of distributed version control systems. Now let's get into the architecture of Git in particular, right? This is the architecture of distributed ones in general. Let's talk about the architecture of Git in particular now. Here, if you see, again, like we discussed, yes, this is the local repository. Sorry, this is the local repository and this is your workstation. Let's say this is my laptop. So you'll have a local repository, this yellow box, which you get a copy from remote repository. Remote repository is shared across the entire team, and you get a copy of it. Suppose now, if you want to make any changes, you will not directly make on this local repo. Rather, there would be another directory called working copy or working directory. Imagine it's another directory. If you are a Windows person, imagine it's a folder or directory, whatever you call it. Okay, so you make your changes here actually. Okay, once you are done with your changes, again, it's not that you push this way. You cannot do this. No, this is not allowed. No. What you have to do, you have to push them into something called staging area. Okay, you have to push to staging area. What is staging area? Staging area is again a virtual layer or else a virtual copy. First, you have to move your changes to staging area. How we will learn, okay, what commands, how we will learn. First, understand theoretically. So you have to push your changes to staging, from staging to local, from local to remote. You cannot directly push to remote or so. This is the flow. It's called GIT tree. It's like a 3 steps before your changes goes to remote. From working directory, you have to put it into the staging area, which is a virtual layer, which is a also which is also called as index area or a virtual area, where all the changes will be pushed from here to local. But you may have a question, what is the importance of the staging area, right? It works like a preview or else a pre-check before your changes goes to local. Means, let's suppose you have 10 files here, you want to move 5 files to local, so you will put only those 5 files to staging area and those 5 files will go to local repo. So you have a better control on which changes are moving to your local. Okay, we are going to see all of this practically. Just understand these points and make a note of it. You will relate to them once we start the hands-on. Right? Imagine working directory is like a folder. Local repository is also like a folder in your local computer. Are we good?
So staging area acts as like a testing area or just like
Kind of.
okay.
Like I told, right? If you have 10 files, let's say you want only 5 files to go to local. You put
Okay.
only those 5 files to staging area. It's like a pre-check. Okay, you see, okay, all the changes were correct. Whatever I want, I have pushed to staging area. See, this
Like
is
moving
not the staging area or the staging environment. Don't relate to that. Test environment, staging. No, this is not that one. The name is staging area, or else call it as index area.
Okay.
This is the architecture of Git, how your changes are moving, how your changes goes to local repo. This is the architecture, flow, how your changes goes to local. From local only, they can go to remote. Directly from working directory to remote, not possible. This is the flow it should follow.
Okay.
And give me here some information like how do you create your local repository? There were multiple use cases on how you create local repository. One use case is, let's suppose, one use case is, let's suppose you have created you already have a remote repo. Let's say you joined a project. It's already some 4-year-old project. You joined this team today. Already remote repo is there. You are asked to make some changes. You will get a copy from remote and create a local repository. Copy from remote and create a local. That's one use case. Second one is, let's assume it's a new project. They just formed the team, a new team, new project. You have to write something from scratch. You have to create your Terraform config files from scratch. So you create a local repository manually, an empty local repository. Let's say you will create, isn't it? First, it will be empty local repository manually, then develop the files, make the changes, then you push to remote. So these are the 2 ways how you create a local repository. One is you get a copy from remote, but let's say remote is not there, it's a new project. You create an empty local repository, develop the files here and then move to remote. These are the 2 use cases. And we will be looking into both of them. I'll show you both. First, we'll get started with the second use case today. First use case also will be covered. First we'll get started. Means assume we are all a team. Okay, it's a new project. So we will create an empty manual repository, manually and local repository, and then we'll push to remote. Am I clear with the two use cases?
Yes.
Appreciate your quick responses. Be attentive and do respond so we can have more productive sessions, more interesting sessions as well. Okay. So this is how you create local repository. We will get into hands-on, but before that, one more thing I would like to tell you, an interesting part. Here we are talking about local repository working directory, right? They are physically one and the same directory. They're same folder, same directory. Okay, physically they are same. Logically they are different. What does it mean? Till now you said from working directory you move to local, but how come they are same folder, isn't it? Physically they are same, logically they are different. What does it mean? Suppose you created an empty local repository. This is a folder, name is demo. This is your local repository. Or else, when do you call it local repository or directory? Let me tell you. Suppose you created a file here. That's it. Then this file is set to be in the working directory. After creating the file, if you add it to staging area, or else if you run the command git add, then it is set to be in the staging area. Suppose after that, if you run command git commit, then you will say it is in the local repository. Means file is physically in the same folder. But as per the status, this is how. The same folder is nothing but your local repository. Physically same folder. The same one is nothing but the working directory. Understood this? You just created a file, kept some file there, means it's set to be in working directory only. You say that file is in working directory. You call that as a working directory. When you add them to staging area, you say that, okay, it's in the staging area. When you commit, then you say it's in local repository. Got this logic, everyone?
Yeah.
Yes.
Yeah. So we are going to see this with the hands-on. So just understand and keep these things noted. We'll look into each of these things now with the hands-on. Good to go? Shall we go and get installed? Good to proceed?
Yes.
Okay. So now let us install Git. By the way, Git works on multiple operating systems. Git works on Windows, Mac, Linux, and so on. It works on multiple operating systems, right? So for Git, you may use your own laptop is fine. You don't need to go for an instance on cloud. Your own laptop is enough. It could be Windows or Mac or Linux. So now, okay, fine. On your laptop, how do you install Git? Just go to Google. All these links, everything will be shared. But let me show you the procedure first. Go to Google and just type in install Git. Okay, go to the first one, the official website, gitscm.com. Go here. Here you will see the downloads. If it is Mac or Windows or Linux, you can go through it. Linux, if it is Linux, you may use apt-get install these commands. Okay, or else if it is Mac, also same. Homebrew install, brew install, git, single command will do. If it is Windows, download the executable, depending on whether it is 32-bit or 64-bit, download the executable and run the executable. You know that, right? Everyone knows downloading an exe and running the exe. That's all. That will install Git. But if you still need any help, if you are looking for step by step, this is the Google Drive, which you will get access once you are registered. There are separate folders for each tool. Here is Git. Git installation on Windows. Everything is there. Okay, with the steps, whatever I have shown. When you run the exe, it will take you through the wizard. Everything is there here with the screenshots. You have to just keep clicking next button. It's as simple as that, but still you have step by step. screenshots for them. Once it is installed, go on launch Git bash if it is Windows. If it is Mac, launch your terminal. Right? So here you may run the command git. See, you will see lot of verbose means git is installed. If you want to check the version, git version. So I have git installed on my laptop. Are we good?
Yes.
Now, okay,
Yes.
git is installed on my system. Let us version control. Let's say I have my project in this folder. Where is the project? Okay, I will create some folder here on my desktop. I would like to use this for the demo. 1 minute. Okay, so now I want to keep all my project files in some folder. So you can create a folder here from the CLI. If you are not comfortable with the CLI, you can also use the GUI. It's up to you. CLI commands, Linux commands, we will learn separately. If you are comfortable with it, if you already into it, you can use, or else you can right click and create a folder as well, new folder. Okay, git demo. I'm creating a folder like this, right? So now I want to keep my projects, keep my project files here and version control this with git. So how do you do? First, go to that folder. CD means change directory. Simple commands. I believe majority of you might be aware of it, but anyone new, CD means change directory, means go to this directory. PWD will show the present working directory. Because I'm using the CLI, like command prompt on your Windows, this is how we can see the path. If you are not comfortable with it, you just go here and do this. It's like I'm inside it. So now I want to, let's assume, I'm taking the second use case. It's a new project, nothing on remote, it's a new team. So I want to create this as a local repository. So how do you create this as a local, any folder as local repository? Go to that folder and run the command git init. Git init means initialize git, start git. This command will start tracking files and folders in this directory. Okay, so do git init. It will show you like .git. If you see here, you are seeing here .git. Right? You are seeing .git. You are seeing .git means this particular folder is nothing but a local repository is created. Here also, like if you want to check out this way, you can check. Do you see .git, a hidden folder? Right? So it means this git demo is nothing but a local repository. Local repository is created. This is your local repository. Okay, fine. It's a local repository created. Now let us create some files and version control with it. Okay, I'm creating a file here. You may, again, I'm telling you, you may use the GUI to create a files, or you may use the CLI commands if you're comfortable. Okay, you may just create some file here, or else I'm creating a file from CLI. Touch file1.txt. It will create the file. See here. Okay, let's suppose I want to add something. Let's say I'm adding some dummy text because my interest is, our focus is not about the content. If you are good, you may write Java program, C, Sharp, Shell, or just text file, anything is fine. Here our focus is to version control them. We are not concentrating on the content of it. It could be anything. If you are a DevOps person, it might be your Terraform configs, whatever it is. So I'm just adding some dummy line. Done. Now, I just want to know where is this file. Can anyone tell me where is this file one? Is it in a local repository or a working directory? As per the discussion, can you relate?
Local directory.
Indirect.
Working
It's
directory.
in working directory.
You can see it
Okay.
with the Git status. It clearly tells you untracked file. Untracked means Git know. Yes. Git know there is a file. But Git know there is a file, but it could not track it. That's what it's saying. It's asking you to add the file. See, add to track. What you should do? Git add file one. Can you tell me now where this file will be?
Staging area.
Exactly. See, changes to be committed. To be committed means, see, always you should have this architectural diagram in your mind. Whenever you are using it, this architectural diagram should be registered in your mind. To be committed means where is it? Obviously, in the
Local rep.
staging.
After committed, it will be going
To be
out.
committed. To be committed means it's in the staging
Staging
area.
area.
Unstaged changes. Okay. So now you can do git commit minus m for message. Message is mandatory. Why I'll tell you in some time. Let's say first file. Some message, some comment. Done. It says, yes, changes are committed. Now, if you see status, it says working tree is clean. Means where are your changes?
Local repository.
Local repository means this folder is nothing but your local repository. It's nothing but your working directory. Got the justification for the explanation I made some time back? I told you it's physically same folder, logically different. Can you justify that now? Did you get justification? Both are same folder. Correct?
Yes.
Shall we repeat it with another file so that things may be more clear for you?
Yes.
Okay,
Yes.
let's create one more file. Now, can you tell me where is this file to?
So
Working directory.
Let's see with the status. Yes, untracked file again. File 2 is untracked. Also, ls will list the files in the directory. Git ls files will list the files in the local repository. See, when I do git ls files, file 2 is not shown because it's still in the working directory. Now tell me, what should I do for Git to track it?
add it to add
Add the file.
Add it, right? Git add file 2. Now can you tell me where is this file?
Staging area.
To be committed means refer this architectural diagram always. Even this architectural diagram, the presentation I used were there in this Google Drive. Okay, here is the PDF which I used so that you could refer when you do the hands-on. So it's in the staging area. So what you should do, yeah, git add. I did already add. It's asking me to commit changes to be committed. What should we do? Git commit minus m. Then what next? I'll give some file name like second file. Done. Now if you do git status, it's clean. Do you see that? ls git ls files. Got it?
Yes.
Yes. Yes.
Right. This is how this is same is nothing but a local repository working directory. Okay, and this is how you move your changes to local. And by the way, remember, we did not go to remote end. Okay, we were still on local. We did not go to this remote repo. What is this remote repo? GitHub Bitbucket works like this remote repo. Sometime back, you're asking about GitHub Bitbucket, right? Those works like this remote repo where you can host your local repositories and share it with others. We will learn GitHub. Again, both are same. If you learn GitHub, Bitbucket would be almost similar. We will learn GitHub. But before going to remote, there are lot many things we have to do here. So I'm not pushing them to remote as of now. We'll do that later. Right? So this is how you move your changes. And here another interesting part is, till now we were creating new files. Correct? And also I'm creating some new files and I'm using some notepad as an editor, right? Like this, I'm opening and making some changes here, right? So you may use any editor, like you may use Notepad, Notepad++, or if you're comfortable with the Linux CLI, if you're already into Linux, you may use VI editor, Vim editor, anything. Those are all different editors. But here I would suggest a very good editor which is used in real time, which is nothing but VS Code editor. You can download this. Again, go to Google and type in Visual Studio Code. That's nothing but an editor. Even developers use it, DevOps persons use it. Okay, it makes your editing very comfortable, a professional way of editing your files. See, you can download this depending on your operating system. It's very easy to set up. Even the documentation for it is available in the drive. So you have to just download and open the application. Let me open it for you. Do you see this? After installation, you will see an editor like this. Go to file, open the folder, whichever you want to work on. What is our folder name?
Git demo.
Correct? Git demo. So see, it's very easy to see your files here. Not only that, you can launch your terminal here itself. Maybe if it is Windows, you may launch Git bash here itself, G shell or any terminal you can launch here. Are we good? Here I can run any commands. Instead of launching another terminal separately, editor separately, I can have all of them. This is called IDE, Integrated Development Environment. It can be helpful to manage any sort of files. Understood?
Yes.
So, okay, here I can see it better also. Till now we are creating new files. Shall we look into modifying the files? Isn't it? In the practice, it's not that you create always new files. You may have to edit the existing files. So how do you edit and manage them with the Git? Right? Let's see editing a file. See here, I'm making some changes. Okay, I'm adding some line. Done. So now let's see Git status. See, always remember Git works with respect to change. The change could be creating a new file or the change could be modifying a file. It works the same. Means whatever changes you have made here, like the new line, will be in the staging area again. Let's see. See, it says changes not staged, but it is not showing like untracked changes. Do you see the difference between untracked and unstaged? You need to analyze the difference between unstaged and untracked. So what is the difference between unstaged and untracked? Unstaged is nothing but for the first time, if you create a file, first time, it will be shown like untracked. Sorry, I wrote it in the reverse one. Okay, for the first time, it's untracked. But file is already there. You made some modifications. Those changes will be unstaged because already the file is in the local repository. Am I making sense? That's why it's
Yes.
not untracked. It's showing like unstaged. Certain changes were not staged. What you should do? Again, the same.
Git add.
You have to do git add and you have to do git commit. Here also the same. You have to do git add and you have to do git commit. But for unstaged changes, because it's not a new file, you can add and commit in a single line also. You can do separately like this, or else you can also commit -a means add and commit with some message. You can do this way because it's not a new file. But for a new file, you have to do it separately only. Right? So let us commit with a single command now because it's not a new file. It's unstaged. It's not untracked. Git commit -am. Let's say file modifications. Right? Now if you do git status, clean means yes. Again, now all the changes were in local repository. Are we good?
Yes.
So understand the difference between unstaged and untracked. See, these basic concepts and basic fundamentals are important. People work on Git and all without knowing these differences, these concepts. But the one who knows these concepts can gain edge over others. So that's the difference between unstaged and untracked. Could be important from the point of interview as well. And yeah. Let me show you one more thing. Till now, we have done commits a couple of times, right? Whenever you commit, a commit ID will be generated, a unique hash code ID. Okay, you can see them with the git log. Git log will give you the history of the commits. Do you see that? 3 times I committed, each time a unique hash code, including the person who made the changes, the date, the timestamp. Some time back we were talking about logging, right? This is what? Monday, May 6th, 8/17. Okay, commit message. Okay, everything in detail. Right? That's what is logging. Also, git log one line. Means if you don't want to see this detailed log, you want to see a brief log. You can also do that. Brief log. Commit ID, first 7 characters are enough. And then the commit message. Commit message is important because in real time, we will give some message here which is relevant to the commit. Or let's suppose I made this commit to create new infra. So I put a message like new infra created. Because at a later point of time, after 6 months, if I see the commit, I should make some sense what the changes were there in this commit. That's why commit message is mandatory. You give more meaningful message relevant to the context. Right? Also, first 7 characters are enough. Meaning, if you want to see what changes were there, git show this first 7 characters. See, it shows you the author, timestamp, which changes were made. See, this high line was added. So it will show you clearly what changes were added, what changes were removed when you look into that commit. So commit IDs are unique, are important. Their history would be maintained and can be seen with the git log command. Push pull, we'll see lot many commands, lot many things. Any questions in this part till now? Are we clear?
Yes.
Let me summarize the things we discussed. We discussed about what is a version control system, who uses it, right? And then we have discussed about types of version control systems, architecture of those version control systems, and then Git architecture in particular. Okay, and then we were trying to understand the Git tree, that's called Git tree or the Git workflow. Like Git init will create a local repository, correct? And Git status will show you like the status of the changes, and Git add, Git commit, and Git log, and Git log one line. Right? These are the different commands we have looked into. As it's a day 1, we started with the basics and we got a clear understanding on working directory, staging area, local repository. This is what we learned today. Any questions in this part? Again, I'm asking to recheck. Are we all good with this? This is what we have learned today.
Yes, it's good so far.
All right. And we were looking into use case that, like assuming it's a new project, there's nothing on remote. So we were developing the local repository. So before we go to remote, there are many things we have to learn, like git diff commands, okay, git remove commands, git ignore, git revert, git reset. Okay, all of this we will learn before we go to remote. Also git branching, git merging, git merge with conflicts, without conflicts, how multiple people can work on the same files, all those use cases and scenarios coming up.
These are all commands, right?
These are all different commands and concepts as well. Revert, reset, these are all different concepts. And yeah, commands with the different flags.
Okay.
And also today we have seen installing it, installing VS
Code
editor. So what I want from your end is, as it's a first day, you should practice all of these things, whatever we discussed in the class first. I'll come to your question, Pradeep. Give me a minute, okay? So whatever we have done in the class, first practice this thing. As it's a day one, first go through everything we discuss here. Then after that, go to our website. You have to do daily hands-on, okay? Without hands, it doesn't work. Go here, go to the quiz portal. You have GIT here. GIT day one quiz. So that you evaluate yourself, you can register the things well. Also, we get the reports once you submit to track your understanding, right? This is one thing. Then after watching the recording, do the hands-on, same things, whatever we do, then take this quiz and then go to the labs here. You have lab. You have it in Drive as well as here you have it in more detail. Like if you go to Git, you have all the commands explained in again. Okay, you can also utilize this for your hands-on. Whatever completed today, that much you can do from here. Even that is done. You have to do these things regularly, right? It's not just you do it after 1 week. Every day you should be doing these practice interview questions. On the particular tool, you go to the interview questions, get started with beginner level because we are in the beginning stage. Slowly, we'll get it. Also, there might be questions which are not yet covered. Git, clone, pull, fetch, all of this will be covered. So you look into the questions which are relevant to the topics. We are done. So this is the practice. This is how you should practice on daily basis. Okay. So any questions, any concerns, you can ask me. There's a question from Pradeep. What is the difference between SVN and Git? SVN and Git both are version control systems. SVN follows centralized architecture. Git follows distributed architecture. That architecture is what we have learned today. Maybe if you joined late, you can watch the recording. Here I have explained centralized architecture, distributed architecture. I have explained Git. Sorry, SVN falls under this. Git is a distributed. Okay, if anyone joined late or missed those things, please watch the recording and get back to me in the next class also. Like, because after watching and practice, you'll get more queries. And during your hands-on, if you have any questions, you will have a WhatsApp group support. Okay, you can post your queries in the WhatsApp group. I believe you are all in one WhatsApp group, right? You will be moved to a separate WhatsApp group, a private WhatsApp group where I'll be there. So you can, there you can post your queries. A private WhatsApp group dedicated for hands-on support.
Preethi,
Yep.
good morning.
Yeah.
I have installed JIT now,
Hmm.
and JIT commit when I give they are mentioning author identity unknown. So where we have to give the author identity to?
Yeah. For the first time, if you are using it, yeah, whenever you are committing for the first time, it will ask for the credentials. Those commands were there in the drive. It's only for this command you have to run. Git config global username, your name. Git config global user email ID, your email ID. This is only for the first time because I have used it multiple times. It doesn't ask for me. Before the first commit, you have to run these commands by placing your name and email ID so that it will register with it. And there is a question from Malik. A question is how to unstage the changes from staging area. Okay, git restore command will do, Malik. Git restore -- staged. And the file name will do.
Okay, so will it move back to working directory?
Git restore stage the file name like file1.txt. That will do.
Okay.
To remove from staging area. But we will learn them. Okay, like we will get to learn like why you should remove, like where you remove and all. Nitin, yesterday there was a demo class, an intro class. If anyone missed that intro class, you have the recording available. You can go through it. Today we started with Git, first tool in the course. Yesterday we had an overview, a big picture of what is DevOps. You can please visit the recording.
Thank you.
Any questions from anyone?
Thank you.
Yeah, hi. So that is all from my end. This is enough for today as we are starting with get the tools installed, get your editors ready, get all the things make sure you are having access to all of them and get started with this hands-on. And we'll connect tomorrow for the next part. Anything else we have?
Nothing else. Thank you.
All right then. Thanks everyone. Good day. See you all tomorrow. Bye everyone.
Thank you.